welcome to the dynamics tutorials. So with this problem, we have two gears A and B that mesh together. I didn't draw the teeth in, but they've got teeth that are intermeshing, and they're connected, intermeshing at this point here, P. So gear A, the small gear, starts from rest at t is equal to 0 with an angular acceleration of 5t, and we want to find the angular velocity of gear B when t is equal to 2 seconds. Gear A has a radius of 10 millimeters, gear B has a radius of 20 millimeters, and each of the two gears are undergoing rotation about a fixed axis. A is fixed about this point, and B is fixed around this point. So our first step is just to figure out the angular acceleration of the smaller gear here, A. Looking at the acceleration, we have that it's a function of time, so it's not constant. So if we want to find the angular velocity, we'll need to set up a differential equation and solve it. So we have that the derivative of the angular velocity of A with respect to time is equal to that angular acceleration of 5t. We'll need to separate variables, so we'll multiply through by dt. This gives us d omega a is equal to 5t dt. Then we can go ahead and integrate this. So again, from the problem statement, we have when t is equal to 0, so that's our lower limit here. We're starting from rest, so that's a lower limit here of 0 for our initial omega a. We're going to end it at time t so that we still have a function in case we need it. And we're going to end this at omega a, so we still have a function in case we need it. Integrating this, we get omega a minus 0, plugging in both limits, and then we get 2.5 t squared minus 0, again plugging in both limits. Cleaning it up, we get that omega a is 2.50 times t squared, and then we'll plug in our time of 2 seconds, and we'll get an omega a of 10 radians per second. Then we'll say that in order for these two gears to intermesh, they have to be going at the same speed here at point P where they're connecting together. So say that the velocity of P on the A side has got to be equal to the velocity of P on the B side. So this gives us that omega a RA, that would be that velocity at P because we're undergoing rotation around a fixed axis, is equal to omega a times RB. That would give us the velocity of P coming from this side. So we plug in what we know, 10 radians per second for omega A, 10 millimeters radius here, 20 millimeters radius here, and the only thing we don't know is omega B, and so we can solve for omega B. In general, when you have these problems where you have multiple objects and they have gears that are intermeshing, or you have part of your system is rolling without slipping, make sure that you use this approach where you set that velocity wherever they're contacting to be equal. Same thing if you have rolling without slipping along the ground. The velocity of the ground is 0. Therefore, wherever you're rolling without slipping, wherever you contact the ground, you're going to have a 0 velocity there. Thanks for watching.